Okay, now I've actually got to do the Spearman's rank correlation test. So I've got some data about long jump distances and cross-country positions. Okay, so I have to adapt the data so that I can use rank correlation to be calculated to test whether there is a positive association between long jump ability and cross-country ability. Okay, so I have to be careful here. In order for my ranks to be consistent, I need to think about what is good. So in cross-country positions, low ranks like third are a good performance. So if I'm going to make that a rank of 1, because that's the best person there, then I have to rank my long jumps in the same way. So therefore, my best ranked long jumper is this 6.82 here. Now I could have done the ranking the other way for both of them. If I start from this being rank 1, then I'd have had to do the same thing for cross country and have the worst cross country runner, which is this person, at rank 1. So you have to just be consistent and be clear about what you're trying to measure. So having ranked the 6.82 as rank number 1 and the third as rank number 1, let's just carry on. So my next longest distance is, I've got a 6.052, a 6.02, which is rank 3. Then I've got a tied rank. In fact, I've got 3 tied. So I'm down to rank 4, so this would be 4, 5 and 6. So in order to give these a rank that's the same, I can't rank them all as 4. I have to use the average rank of 4, 5 and 6, which is the middle one, 5. So these will all be ranked 5. Okay, so I've used up ranks 4, 5 and 6, so my next available rank is 7. So shorter than 5.93, my next one is 5.61, so that will be rank 7. But then I've got a tie again. I've got 5.21 for ranks 8 and 9. So the average of 8 and 9 is 8.5. So my tied rank is 8.5 here and here. And then all on its own as rank number 10 is this 4.84. That was the worst person. Now I've got to do the cross-country rankings. So the person who finished third is in rank 1. The person who finished, what have I got? I've got a 12th. Anyone beat 12th? No, so that will be rank 2. Okay, you can cross them out as you go. And then I've got 35th is going to be my rank 3. Then there was a tie for 39th place, so that's ranks 4 and 5. So the average of those is 4.5. That's my tied rank. And then I've got 43, I've got 84, I've got 47. 43 is going to be our next. So I've used up 4 and 5, so that will be rank 6. Then 47th will be rank 7. 68th will be rank 8. And 9 and 10. So I've done the conversion of the raw data into ranks, and now I need to carry out the test. So I've got my 5 stages again. So first stage is hypotheses. So there's always help in terms of looking what the test is going to involve. So the test is going to be of whether there is a positive association between long jump ability and cross-country ability. So I can just copy out the contexts. And remember that H0 is always nothing interesting going on, so that will be no association. And H1 will be some kind of association, but that's where I have to be careful about whether it's 1 or 2-tailed. So my hypothesis for H0 is going to be, so hypotheses look like this. Now for H1, okay, this is where I have to be careful. There is association, but what kind of association? Well, we are looking specifically for a positive association. So I need to insert that word in H1, and that means that this is going to be a 1-tailed test. Okay. Right, now I need to work out this test statistic. Okay, now I can use exactly the same calculator method for Spearman's as I did for PMCC, as long as I forget all about the original table of data. Don't need that anymore at all now, and I just enter the ranks. I can still use the same mode on my calculator, it's just I have to be careful to enter the ranks instead. So on menu, I do menu 6, I go into option 2, and I'm going to put in my rank data. So there's my data entered, and if I press option and choose option 4, then I can see R equals 0.231499. So that's 0.23150 to 5 significant figures, and that's my test statistic. Now I need to look up my critical value, so I need to go to my tables, but before I do, let's get the things we need. So is it one or two-tailed? Well, I said it was one-tailed. I'm interested in the positive tail. So it's one-tailed. Okay. Significance level. I've got to use a 2.5% significance level. And I need an N value, and there were 10 athletes, it told me at the beginning of the question, or I could just count the number of pairs of data. So N equals 10. So one-tailed, 2.5%, N equals 10. Check that I really do have the Spearman's page. Okay, so I am doing RS, so I need Spearman's, and I need N is 10, so I'm on this row, and I need to be 2.5% for a one-tailed test, so that's the middle column, and it's this value here I need, which is 0.6485. So there's my critical value. Now I've got to do my comparison. Oh, there's only one critical value because it's a one-tailed test, and I do want the positive one because I'm interested in a positive association. Okay, so I need to compare my 0.2315 with my 0.6485, and I can see this is less. Now, in order to be significant, I'd have had to be higher than this critical value. So therefore, this is not significant, okay, at the 2.5% level. And therefore, if it's not significant, I always give H0 the benefit of the doubt, so I accept H0. And my conclusion in context, because I'm accepting H0, we always say we have no evidence of something, and to work out what we don't have evidence of, we look back at our statement of H1, or double check back with the question. But if you've carefully stated H1, that's what you don't have evidence of. So I don't have any evidence of a positive association between blah-de-blah and blah-de-blah. But of course, you've got to write out long jump performance and cross-country performance in full. This is in context, so you do need to actually put in all the words, otherwise you could lose marks. And also, although I've mentioned my significance level, really in my conclusion I should say no evidence at the 2.5% level. Okay, always helps to say things, if necessary, more than once, just to make sure you get the marks. Okay, and then we've got a familiar looking final part. Why may it not valid for all athletes? Well, what am I told? What am I not told? I'm just told there were 10 athletes and they all come from the same club. So you're not going to be surprised to see that the comments are, firstly, because they're all from one club, conclusion may not hold for other clubs, and secondly, because I'm not given they were a random sample, the conclusion may not be valid even for everyone at this club.